All right. Let's just do kind of a quick verbal vote here. A goes with 3, 4, or 5? 5. B goes with which one? 3. And so process of elimination says C goes with 4. Now I'm curious to find out how we decided which goes with which. So let's start with number 3. Tell me what you guys used to be able to narrow it down and come up with option B for number 3. What did you see, or how did you eliminate the other 2? Which one? Yes, 0.15 for the tip. And it tells us that X is the number of dollars that a customer spends. And so we put that here. What would we find by taking 0.15 and multiplying it by the dollars spent by the customer? What would that tell us? What would our output be? If I take 0.15 and I multiply it by the dollars that a customer is spending, what would I be able to calculate? Yes. So Y, or the output, would be the total amount of the tip. All right, so that's how we figured out number 3. What about number 4? How did we know that that was C? Tell me what you saw or how you knew to eliminate the other options. How did you know it had to be C and not A? I like it. There's no 4 in there. The top one has this weird +4 on it, and there's nothing about the situation with the Florida sales tax to lead me to believe that we would have to add 4 on top. I like it. What does it say the sales tax in Florida is? 6%. Can anybody tell me how to take a number like 6% and write it in its decimal form? Yes, sir. 0.6. Very close. 0.6 would be 60%. 6% is 0.06, but I love it. Thank you for volunteering. Does anybody know why we moved the decimal 2 places for a percent? Have you guys ever heard of a compound word before, like in your English class or elementary school when they talk about compound words? What is a compound word? Yeah, they take 2 words and they smash it together and they say, it's 1 word now. But it's really made up of 2 separate words that each have their own meaning. And when we smash them together, it's 1 word that has the meaning of these 2, right? Percent is a compound word. Here is my dividing line between the 2 words. I have per. Have you guys ever heard the word per before in Algebra 1? What's another way of saying per? Other key words? Yes, sir. For each. Yes. Per, for each, for every. What's this cent? What does cent mean? Do you ever use cents and dollars? How many cents are there in a dollar? 100. So this compound word literally means for each 100. Or out of 100 would be like a clearer way for me to remember this. But it's coming from that compound word. So I'm always going to take whatever they tell me in a percent like this, and I'm going to divide it by 100 cents. And that's how you can get the decimal when you want to change it from a percent into a decimal. So I'm curious, because this has 1.06. What do you think that 1 means? Like, why is it there? Why didn't they just have 0.06 for the sales tax? Yes, sir?
It's a whole number.
It is a whole number, yes. If I take 106% and I want to change it into a decimal, 106 divided by 100, do you guys know what that is? Grab your calculators if you don't. Grab your phones. What is 106 divided by 100? 106 divided by 100. Head up for me, dear. $1.06. So this 106%, 100% plus 6%. You guys agree that those two would add up to be 106%? That 100%, that is the whole price of whatever it is that you want to buy. And then on to the price of whatever it is that you want to buy, they're going to add 6% for your tax. Whole price of what you want plus the tax to get 106%. That's what you have to pay for when you walk out. Because you have to pay for the item, not just the tax, right? That's why we have that 1.06 in the front. So if this is going to calculate 100% of the thing I want to buy, plus the 6% on top, and they're going to put it together, what would this whole thing tell me then? What would I be finding by doing 1.06 times X, the price of the item? Why would I want to do that? Close. It tells me X is the price of the item. When you're in the store and you're buying something and you pick it up off the shelf, do you usually know how much the price of the item is?
Yeah.
It's either on the shelf or there will be a sticker on there or a tag that tells you the price of the item. What do you not know when you're walking around the store picking up stuff and adding it to your cart?
The total.
The total. This is going to tell you the total at checkout. So Y, the output, is the total cost at checkout. Does that make sense? Okay. Let's look at the last one. We know that it goes with A. Even if you didn't know that it went with A, but you got through the first two, process of elimination says there's only one choice left, right? I have two questions about this one. That's a relation mapping, like what we did in our bell work yesterday. Is that one-to-one? Why not? You are correct, by the way. It is not one-to-one. What do you see that leads you to say it is not one-to-one?
3 and -3.
Yes. 3 and -3 are both mapping to -5 right here. Two inputs are going to the exact same output. To be one-to-one, one input goes to one output and no other inputs go to that same output. We matched it with an equation, but how is it that we have two numbers that are different that are going to the same output? How is that possible? I want to look at the equation for a hint. What do you notice in equation A that could help us figure out why two different inputs are going to the same exact output? What do you notice in this equation that's not in either of the others? What do we see? The squared. Yes. This right here is why my whole thing is not one-to-one. It's why it's possible for me to have two inputs going to the same output. What does it mean for something to be squared? Multiply it by itself, right? So that means if I take 3 and I square it, that's the same thing as saying 3 times 3. What is 3 times 3? 9. So if I take negative 3 and I square it, what am I multiplying together? Negative 3 times negative 3. And you know that a negative times a negative is what? Positive. So negative 3 squared is what? Also 9. Two different inputs, same exact output. I didn't finish up the rest of the operations in the equation, but I wanted to just investigate why is it that I can have two numbers that have the same output here. All right, we're going to be in your books. We're going to talk about a concept today that we have already started talking about. We just haven't used the formal name for it yet. We're going to be on page 7, where we are going to talk about types of notation. Okay, Ian, head up for me, dear. Thank you. We're on page 7 now. We've been talking about and using algebraic notation. This is my inequality notation, like x is less than 2. I want you to look at that number line. Why do they have less than instead of less than or equal to? It's pointing towards what? I'm sorry. Pointing towards the x? Yes. Yes, yes, yes. So, sorry, I misunderstood. You were talking about this guy right here, and I was like, it's pointing towards the x? I don't see an x up here. But then I tracked my eyes down, and I saw what you saw. Arrow's pointing to the left, so I can almost think about this like an arrowhead pointing to the left. But we don't have that little or equal to underneath it because it is an open circle there. I'm going to draw a very similar graph off to the side. 2, 1, 3. I'm not going to write in all the other numbers. But if I had a filled in dot right here and pointing to the left, how would I write that in algebraic notation or inequality notation? X is less than or equal to 2. So far, so good? Okay. We've been talking about and using that kind of notation for quite a while. I have started you guys on interval notation. We're not going to talk about set builder notation, so you can cross that out. And this whole bullet point right here, those 3 lines, you can cross that out as well. We are not going to talk about those pieces. It's not that it's bad, it's just extra, and we don't need it. Interval notation. This is the one that I've had you guys using for a couple of days, but we haven't had a name for it. You know when we've been talking about domain and range, and sometimes we write it with an inequality, and sometimes I have you write some parentheses? That's interval notation. So we're going to practice that more today, and we're going to dig into that. My interval notation. If I have something that looks like this one right here, it has that open dot, or I've got this. That's the same thing as this. It's representing the same thing. It doesn't have that or equal to underneath it. My interval notation for that So when we write interval notation, we always put the smallest thing first, and then we put the biggest thing. So I'm looking at this number line, and what do you notice about the arrow in this number line? It's pointing left. What kind of numbers live over here? Negatives. Because it has an arrow on the end, I know that it's going to stop Never. So it's going to continue on forever and ever and ever and ever and ever into the negative numbers. How can I write that with a symbol? Negative infinity. So I start with the smallest, and then I use a comma, and then I write the biggest where the shading stops, which in this case would be 2. My interval notation on the outside of this either uses parentheses or these little square brackets. Here's how I decide which one it gets. If it is an open dot like this, so if it does not have the or equal to, I'm going to use a parenthesis there. So there's an open dot at the 2. I use a parenthesis by the 2. I need something on the other side. I said that we use a parenthesis when it's open. If I have the or equal to, if I have a filled in dot, that's when I use the square bracket. Can I ever be or equal to infinity? No. Is infinity a number? No, it's an idea, right? It's the idea that you keep going on and on and on and on and on. But I can't ever be equal to it because I can't ever get to infinity. So we're always going to use a parenthesis when we see an infinity because I can't be or equal to it. We're going to write our interval notation for this one now, which is very similar. And then we're going to look at some examples where we get to practice this. Interval notation. This is almost exactly the same as this one over here, correct? What's the only difference? I have that filled in dot. It's shaded inside. So the smallest is still negative infinity. The largest is still 2. You told me I can't ever get to negative infinity, right? So I'm going to use a parenthesis there. Do I have a filled in dot? Does it have the or equal to with it? That means I'm going to use a square bracket. So far, so good? Let's practice it. We're going to look down at the bottom of this page. There's a graph there. We're going to determine the domain and the range. We're going to write this in inequality notation, algebraic notation, and we're going to write this in interval notation. And I'm going to start by getting rid of the set builder notation. We're not doing the set builder. So we can just cross that out right now. When I'm talking about domain, does that go with x's or with y's? X's. Which way does the x-axis go? Left and right. So when I'm looking for domain, I'm looking left and right. Look on the left-hand side of the graph. Is there an arrow on the left-hand side? Yes. It's mostly pointing up, but it's pointing a little bit to the left, right? What about the right-hand side of the graph? Same thing? Yes. Can I trace from the left-hand side to the right-hand side without picking up my pencil? Yes. This keeps going left forever and ever, so I can get any kind of negative number. This keeps going right forever and ever, so I can get any kind of positive number, and there's no breaks or jumps or gaps in here. So they even wrote this down for us. Our domain is all real numbers. What's a symbol that I told you guys you're allowed to use for all real numbers if you don't want to write all 3 words out? Yes. It's an R that has like a double stick on it. Yes. Can you abbreviate that as ARN? No. But you can write all 3 words, or you can use that R with the double stick. Now I want to write this using the interval notation, and we've practiced this for a couple of days now. All real numbers, we said we can get any kind of negative number we want to. Going to the left, that's right here. What's the biggest it ever gets on the right? Remember, I'm only looking left and right for barriers. I don't care about up and down at all. -1. So -1 would be like right here. Does it stop right there? 1. Does it stop right there? No, I have an arrow here. If I could zoom out on this like Google Maps, would it keep going off to the right and getting to bigger and bigger and bigger numbers there? If I zoomed out really, really far, could I get to any kind of big number with enough zooms? So when does it stop going out to the right? Never. How do I say that? Infinity. -infinity to infinity. Why do we have parentheses around it again? I can only put brackets around things that are numbers. I can't ever be or equal to infinity. We use the brackets when it's or equal to. I can't ever be or equal to infinity. All right. Range. It says the least. What does least mean? What does the word least mean? Give me a synonym. Smallest. The least, the smallest y value is what? -6. I don't like the way they printed this graph because if you're just looking at the numbers, it almost looks like -5. I had to look really carefully at the y-axis to see that they were counting by 2s.
Is it supposed to be like on the side?
Is it supposed to be on the side? What do you mean? I'm sorry, I don't understand.
Like, very much, it's not always at minus that. It's the same up there. Like, see, it's not
Oh, I see what you're saying. Okay, so here's what they're asking for when they say the smallest y value or the least y value. Do you guys see how this is the lowest down point of the whole parabola? If I wanted to write the ordered pair for that, it is 1, -6. I am looking for the smallest y parts of any of the ordered pairs. So it doesn't matter that it's not touching my y-axis right there. I'm going to find the lowest down part, and then I'm going to read the numbers that I want when I'm talking about the range from the y-axis. Does that make sense? Okay. So that's what I'm looking for there. It says the range is all real numbers greater than or equal to -6. We said that this was the smallest. Why are they now saying greater than? What are all the other y values if I were to write down these ordered pairs? Are they greater than or less than this guy? All the other y values are bigger than this, right? This one is the smallest, the least. All the others are bigger. How do I write inequalities about the range? What letter do I choose? When I want to talk about the range, what letter do I use, X or Y? Y. So Y. And then I want to write the rest of this using inequality notation. Greater than or equal to -6. Alligator eats which thing? Does the alligator eat the Y or eat the -6? Y. It says that the range is greater than or equal to -6. Up here it said that -6 was the smallest, so I know the alligator can't eat the smallest thing, right? Alligator eats the biggest thing. So far, so good? Because it has this or equal to right here. Whenever you see or equal to, that's when we get this guy. When I look on my graph, even though they didn't put it on this picture, if I put a dot down here, that graph actually does go through that point. So that's why we have the or equal to there. Does that make at least a little bit of sense? Okay. And then they wrote our interval notation for us down here. I know where the negative 6 came from, but why didn't they put that second? Why don't they have negative infinity and then a negative 6? Why did they write it in this order? Why is it not switched? Yes, sir.
That number came on the x-axis. -6.
Close. Negative 6 did come actually off my y-axis. It came from right here. But what did we say about this number? It was the smallest. I always write the smallest number first. Where is all the rest of the graph? Below or above that? Above. When I go up, are the numbers getting bigger or smaller? Bigger. That's why I have the infinity second. That's the biggest. That's the smallest, the lowest. Why did they put a bracket? I just didn't hear you. It's a number. It has this or equal to right here. It's actually a point on my graph. My graph goes through that point. So I have this bracket right here because it is or equal to -6. Why the parenthesis over here? It's not or equal to infinity because we can't be or equal to infinity. Flip the page for me. Next example's on the next page. We're going to do domain and range here in both interval notation. You guys have lines underneath the graphs. My screen cut those lines off. I don't know why. I'm going to do domain in red and range in purple. For domain, I'm looking which way? Left and right or up and down? Left and right. And if I have to use a letter, which letter, X or Y, goes with it? X. So I'm looking left and right. I feel like we've seen this weird M-shaped graph before. Did they use that earlier in the notes? Okay. I just felt like it looked familiar. So I'm looking left and right. I don't care about the up and down part. Any numbers that I might use have to come from the X-axis because I'm going left and right. Let's look at the left-hand side. Do I have an arrow on the left-hand side? Yes. It's pointing mostly which way? Down, but it's also tipped a little bit to the left. Will it ever stop? No. How do I say it's never going to stop going left? Negative infinity. So from the left-hand side, where it shows up on my picture, I can trace over to the right-hand side. Do I have to pick up my finger to get to the other side? Cool. I get over here. What do you notice? There's another arrow. It's pointing mostly down again, but it's also tipped a little. How do I say it goes right forever? Positive infinity. That's my interval notation. I want to use the other kind of notation here too. If I can have any kind of negative number, any kind of positive number, no restrictions on anything, how else can I say that? All real numbers. Now we're going to do our range. Do I care about left and right anymore? Nope. Now I'm looking which ways? Up and down. Let's start with down. What do you notice about the bottom part of the graph? What do you see on the bottom of the graph? We've got arrows pointing downwards. What kind of numbers live down here? Negative numbers. Does it ever stop going down to the negatives? How do I explain that? Negative infinity. Parenthesis because why? Why am I using a parenthesis around the negative infinity? I can never be or equal to infinity. And then I use a parenthesis, or sorry, a comma after that. So we looked down, now I want to look up, right? Does this graph have an arrow that points up? No. The y-axis points up, but the graph, the blue thing, doesn't point up, does it? So what do? Where does it top out at? Looks like 1, 2. Everything is below that, right? And that is 3 on the y-axis. That is the highest it ever goes. 3. If I put a dot right here and a dot right here, does the graph actually go through those points, or does it have holes there? Goes through. If there's holes, they have to show me the holes. They would have to put them on there for me. So bracket or parenthesis here? Bracket, because it does have that or equal to. All right, let's write this using inequality notation. What letter do I use for range? Y. What number am I going to need? I'll worry about the sign in a minute. 3. Is that the biggest or the smallest on the graph? Biggest. Alligator eats the bigger thing. So it has to go this way. 3 is the biggest. Everything else is below it. Let's do our diagonal line. And then we're going to go look at a weird graph. Which ways do I look for domain? Left and right, yep. Is there an arrow that points even a little bit to the left? What about even a little bit to the right? Can I trace between the left hand and right side without picking up my pencil? So what is my domain? Negative infinity to positive infinity. Or I could write that how? All real numbers. For range, I want to look which way? Up and down. Let's start with down. Is there an arrow that points even a little bit down? Even a little bit up? So what is my range? Negative infinity to positive infinity. Or I could say that as all real numbers. Beautiful. Do you remember yesterday when we talked about discrete and continuous? What does discrete data look like? Dots. Looks like we're going to connect the dots. What does continuous data look like? Yeah, it's like you've filled in a connect the dots. Like there's lines connecting everything, or curves. It's not always straight lines, but you don't have to pick your pencil up, right? Go ahead and flip to page 8 for me. Is this graph continuous? Or sorry, you guys were already on page 8. My apologies. Is this graph continuous? No. Why not? There's a break in it. We would have to jump, right? I can trace along the left-hand side. Then I'd have to pick up my pencil and jump. Does that mean it's discrete then? So how would I label this? Neither. I need to learn how to write domain and range for something that is not discrete and not continuous. We are not going to do the set builder stuff again. Get rid of the set builder. I'm going to keep asking this until everybody is really sick of me on this. Domain. Which way do I look for domain? Left and right. What axis goes left and right? The x's. X-axis. So I'm looking for any numbers for domain. I get the numbers from the x-axis. All right. On this side, I have an arrow, right? Continues on forever. I'm going to put my pencil down here. And I can take my pencil all the way up to here before I would have to pick it up, correct? Any numbers I want for the domain come from what axis? X-axis. What's the x part of this ordered pair right here? -1. The graph is on the left-hand side of -1. Are these numbers over here bigger or smaller than -1? Smaller. So they are less than. The domain is all real numbers less than -1 or greater than. I'm going to pick up my pencil from here and I'm going to jump over here because these are all bigger than this right here, right? But I need another number. What is this on the x-axis? 0. Is greater than. Just greater than? Or do I need to add that or equal to? It is a closed circle. It is a filled in dot, so I have to add that or equal to. Greater than or equal to. Zero. I don't like the way they wrote this here. I don't like the way the blanks are. So I'm going to write it off to the side. I just feel like it gets confusing if I try to fill those in. So I want to try to write this using interval notation. They have a parenthesis and a negative infinity, comma, -1. That goes with this dot, right? Would I use a parenthesis or a square bracket if the dot looks like this? Parenthesis. And then they have this right here. This is called a union. This we will use when there are jumps or gaps. Unions put things together. So I'm saying part of my graph is over here, but part of my graph is over here, and I want to put those together and talk about them as one piece. So that's what I use that U for. Where on the x-axis did we say we picked up again? At 0. And then it continues on to the right forever, right? So infinity. When I look at their notation, they have a square bracket around the 0. Why? Yep, it's a closed circle. It has that or equal to with it. What do I always use around infinity, though? Parentheses. So far, so good? Okay. The range is all real numbers. Range, I'm looking which way now? Up and down. We are almost done, guys. So if I need to use a letter to talk about the range, I use what letter? Y. Now I'm looking this way. It's all real numbers up until where? -1 again. So all real numbers, it's below this. So again, it is less than -1. Then I would have to pick my pencil up and jump, right? Where am I on the y-axis now? 2. And above that, how do I say above? Greater than. Greater than. Do I get the or equal to? Yes. or equal to positive 2. All right, so let's write our interval notation. Negative infinity, because I have an arrow pointing down, up until I get up to what? Negative 1. Should I have a parenthesis or a bracket around my negative 1? Parenthesis. Why? Because it's open. Then I need what kind of a symbol? Because I got to pick up my pencil and jump. Union, U. I pick up again up here. What number there? 2. Should I use a parenthesis or a bracket around the 2? Bracket, because it's a closed circle. Does it ever stop? Infinity. Parenthesis or bracket? Parenthesis. Beautiful. Beautiful, beautiful, beautiful. So far, so good? All right. I want you guys, this is the last thing I'm going to ask you to do today. I want you to try to write the domain and range using interval notation. Check with this here. This is the last thing we're doing. Did you do this one with us here? Go ahead and do the check. Just try it, and then we'll compare it. That's the last thing we're doing. Mm-hmm. So if I look at 1 on the x-axis, that's right there, right?
Mm-hmm.
So the domain is just now telling me only about this. I also want to include this. I have to find a way of writing that.
Let's write like this.
I want you to write it like this guy. That's all right.
What did you?
Mm-hmm. For which piece?
This part, because it's there, since it's going down, it's going to be negative.
Negative infinity. Are you doing domain or range?
Domain.
Domain. So we're going to read our number off the x-axis for domain.
Okay, so it's enough.
Yes.
And since it's open gap, there's going to be parentheses.
Mm-hmm. All right. Range is really tricky on this one. Let's look at our domain. I'm only looking left and right. All my numbers come off the x-axis. We're going to write this in interval notation, so parentheses and brackets. Is there an arrow that points even slightly left? Yes. So how do I start this? Because I always start with the smallest. Negative infinity. So from all the way on the left, negative infinity, where this arrow is, now I'm going to put my pencil down here and trace along it and see what happens. Tracing along my graph until I get here, and then there's a hole. Where am I on the x-axis when I run into this? Careful. -1, because I'm still on the left-hand side of the y-axis. -1. Parenthesis or bracket there? parenthesis. Why? Open circle. Do I have to pick my pencil up? Yes, I do. So what symbol do I put down now? U for union. I pick up again over here. Where am I on the x-axis when I put my pencil down again? That's -1? 1, because remember, for domain, I'm always reading my numbers off the x-axis. For range, I'll read off the y, but for domain, I'm always going back to the x-axis here. So +1, bracket or parenthesis there? Bracket y, closed circle. And then I follow along, and I hit the edge of the graph, but what do I see? An arrow. What does that mean? Infinity. There's my domain. If you got by your own assessment, if you got about half of that right, give me a quick thumbs up. Cool. That's actually really good. This is very hard to write, by the way. So if we got about half of it first time through, I'm cool with that. Range. I'm looking which way for range? Up and down. Any numbers that I write will be coming off of the y-axis. So I start down. I have an arrow that points down, right? And I follow along until I get to here. Where am I on the y-axis now? 1. Is there anywhere else that there's a y value of 1? Anywhere else on this graph that if I plotted the point, it would have a y part of the ordered pair of 1? Let's look. This ordered pair -1, 1. What's this ordered pair? 3, 1. Is it on my graph? So there is somewhere else on this weird looking graph where there's a y value of 1, right? And it continues going up after that. If I were to make a table for my outputs, my y's, somewhere on this graph, can I get every single y value that ever existed? I got to jump over here to get some of the rest of them. But there's nowhere where I have to pick up my pencil and go higher than I was before. There's nowhere when I'm looking up and down that there's not a line connecting dots somewhere, right? From here and below, I got that all filled in with an arrow. From here and above, I got that all filled in an arrow. I don't have to pick up my pencil and go higher. Does that make sense? My range on this is all real numbers. Even though I have this break in the graph, when I pick up my pencil from up here, I go to y values that I've already visited and keep going. So my range goes from -infinity to +infinity, or all real numbers. We'll hit on this idea again later. If that didn't make sense to you, but what we did earlier in the lesson today made at least a little bit of sense, we're good. Like I said, this was a very, very hard range. You guys have the remainder of our time together today, including your study time, to work on the homework. This is the entire assignment because this is the last class period where we talk about lesson 1.1. Our homeworks, give me just 1 second here. Our homeworks, as a general rule, will be submitted on Canvas. However, this week, Canvas really hated me. I don't know what is going on with Canvas, but when I went in to make this assignment in Canvas, I could type a whole question in, and when I went to click save, it said, the item failed to save. And it kept doing that over and over and over, even when I refreshed the page, even when I started a new assignment. It would not let me do it. I've been working on it all week, and it just didn't work. So for this first assignment, until I can get these bugs worked out, I want you guys to do this on paper in your books. You will not need to submit this to Canvas. I will check it in class on Monday. I'll come around, and I'm looking mainly for completion right now. And then I'll take any questions you guys have about the assignment, okay? I will also make sure to post the answer key on Monday so that you guys have access to that as well. This won't be our normal, but rather than throw my computer out the window, which is what almost happened, just decided to take the stress away this first week, give you guys some time to roll into it, and then we'll get it figured out after that, okay?